See, we do one thing. Instead of searching this particular resistor, so we can search by V bias. Okay. Now in D23, so voltage is available or not, that once again I will check. Voltage available or not. See, D23. Not available. One side it's available, it's 1.011. okay. There is a plus and negative. See, this negative side, adapter ID, okay, adapter ID is available here. Adapter ID, this is the one, pin number 1. So this one is anode, it's a positive point, there is no voltage. See, here I am having little doubt, so let me check this V bias is available or not. This VDAP, VADP we checked here, but here availability in this particular diode is not available. V bias we can check, okay, V bias. See, it has come to Q527, okay, Q527. We will search where it is. For temporary I will disconnect. See here, Q527, fourth one. So 1, 2, 3, 4. This one is Q527. Here we will check its V bias is available or not. See, this one according to the schematic, Q527 is P channel MOSFET, okay, it's a P channel MOSFET. See the diode direction, okay. Here gate number 1, 2, 3, source and drain, means in 3 leg here will be the gate, okay, and here will be the source. This one is drain, pin number 1, 2, 3, okay. As per the schematic, pin number 1 gate, 2 source and 3 diode. So drain goes to where somewhere here. Diode, okay, diode positive point. So here we will let us check the voltages. Gate is not available. See, the gate is not available. Source is 1.4 volts. Which one is source? See, limit signal is available here, okay. If there is no voltage in gate, so here limit signal should pass through source to drain, Okay, so let me check. Here is the drain. See, drain is available here. Drain is available, okay, which is connected to D513 pin number 2. 1 2 3. This is a diode D513. This is the one. See, these two are positive and this one is negative. Okay, it's a negative common diode. Here positive pin, you need to check. Yes, it's available. Drain voltage is available. This side is not available because after switching on, after power on only, this voltage is available. Okay, so here it's a common cathode, so that's the reason we can consider only this one. So here voltage should come in 513, diode 513. It's not available. Here it's not available. See, in this circuit something wrong. OCP A in, OCP A in, we have doubt in this particular circuit. Okay, V bias, why it's not available? Gate voltage, drain is little bit available. See, sometimes what will happen in case of problem with the diodes, then it won't allow some voltages here. Okay, there either this V bias section may be the problem, or forward of this section may be the problem. Okay, so we do one thing. It will be in off mode, but here it's in good condition only. Source to drain, to pass. Here, see, in this diode, here voltage we are getting, right? It's a 0.5 something we are getting. It should pass to here in this section, pin number 3, but we are not getting here. Okay, this may be the reason, I think so. Here voltage we are not getting. Okay, we do one thing. In some cases the protection diode will give some issues. Okay, first we do one thing. We remove the diode and we'll check the voltage available is there or not, somewhere here or here. Here voltage is there, but here it's not passing, right? So that one I have doubt. So first we remove this one, and then if there is no result, then we remove this one, and then we remove and check this input output sections. But here I am sure this one after power supply only it's available. Okay, now D513, it is D513, D513. I will remove and check. Okay, see, now I have removed D513. Okay, I'll show you. Removed D513. Okay, here is the component. It's a D513 diode. Now let me check the result. See, if we remove any one component, anything can be done. So that's the reason, for safer side, I'll remove, either I'll remove the processor or I'll put the heatsink. Okay, so best option is I will remove the processor, and let me check, because some damages might happen. Anyway, see, the RAM also I fixed here, but anyway, that also I'll remove. Now let me cue the power supply and DC jack. See, I'm connecting now. Hey, little bit it got increased. See, before DC machine reading was 0.006, right? So let me check adapter ID. What is that? As per the schematic, what we are searching, what is that? What we are searching, adapter enable signal, right? It's Q34. I'll check Q34. Let me check Q34. Q34. Some improvement happened here after removing the diode. Aha, see, both the gate are active. Somehow something we done. See, adapter enable has come, means here voltage divider has happened. Okay, has to be happen here. It's R, what is that, R589 is the R1, and here it will be R2. So let's calculate. See here, what is the formula of voltage divider? It's R2 divided by R1 plus R2, means it's a 200 plus 150, 350. It's a R2, sorry, R2 is 150 divided by R1 plus R2, it's a 350. So this is the total into 19.53. It's 8.3 approximate 8 voltage should come here. Okay, so let me check in gate of this particular MOSFET, Q533. Q533, where it went? Where it is? So to search this side. This is the one, Q533. Here is the source and the gate. 1, 2, 3 is the source and gate. Let me check. So this one is source and the gate, yeah, 7.63. See, it's a 8.3 volts, approximate 1.7 volts to, I mean, it's 1 volts to 13 volts we can give to where gate of the MOSFET. So then we can get the output result here. See, let me check its output, what we are getting. See the drain, Now I'll check the CLR. Where it is? CLR. Yes, this is the CLR. Haha. See guys, without removing multiple components, we got success. You know, this Wien section got succeeded. See, once again I'll explain you whole theory of this one. See, first we connected DC jack. From here to here we were getting only VADP, and here it was coming to source, and here gate voltage was 15 point something was there, because here voltage divider is there, but we should not consider it as a voltage divider until unless this goes to ground. Here when we checked this Q34, VCC 1 and 4 ash was there. I mean, it's a gate 1 was 3.3 volts, gate 2 was giving beep. It's a digital beep. When we confirmed with and without voltage, then I mean with and without supply, then we got considered it's ADP enable was giving digital beep, and then we searched by this one VADP. All circuit we searched. Even op-amp also we searched, so one side it was working fine and other one was not working because of this V in signal. See, VADPBL was not there, that is a major issue, and now we searched by ADP enable, and then we got this point. Where is that? So anyway, we will search once again. Just a minute, which point, some signal, V bias, I'll search, just a minute. V bias, see this section we got, here we had some doubt, so VADP was available or not, and then we searched this one, V bias, and when we searched one by one, this V bias was going to Q527. Here some malfunctioning was there, because see here we were getting voltage, but here it was not passing through this diode. Means it's a pin number 3, we should get some voltages, and here it was some voltage and here it was not there. Means it's a protection diode actually. Okay, this one is OCPA in. See, this voltage were not there, and this is the protection diode. In some cases what will happen, if voltage any malfunctioning happens in V in section, this circuit will break out and it protect the other circuits. Okay, this is called the overcurrent protection. Because of this diode, it's a D513, so we were not getting any voltages in this. Okay, so now let me check with processor and RAM and heatsink, everything I'll put, and I'll check once again display. See, I'll take the processor. It's positive. This is the positive. Connected. We'll connect heatsink. So we're supposed to put the heatsink paste, but anyway later we will paste. First we will check the result. We got the display or not. And RAM. Actually this is not DDR2, it's a DDR3. Okay, somewhere I mentioned it's a DDR2 by observing some sections. Okay, anyway it's a DDR3 volt, DDR3. Now I'm giving supply. I'll connect to keyboard. I'll connect to keyboard. Okay, let us check the amp and keyboard section. Everything is looking here. Anyway, I am giving supply here. See, I removed the CMOS. Once we remove the CMOS here, so it should on it by itself, automatically it should on. Okay, I'm connecting DC supply. See the reading? It's reached approximate 1 amp. It's a 0.915 amp. Okay, display not yet come, but one plus point is it's switching on, right? We succeeded in V section. We succeeded in V section. That is a major success. Okay, here there is no display. I will clean the RAM and again I will put here processor. We not did tight, I think so. Anyway, once again I will open or not. Here it's connected properly. It's locked only. Also I'll clean the RAM. Okay, let me check now. Connecting. See the DC machine. Increasing to 1 amp, 9. Guys, it's a success. See, the display also came. It's running successfully. See guys, by this case study, so I wanted to inform you people, please don't spoil the motherboard. Okay, please don't spoil the motherboard. Try to do advanced level checking. So remove less components or replace less components. Just by idea itself you will get success. Okay, so once again I'll repeat. So give some times for thinking. So think well and do well. So remove less components. Don't work out on multiple ICs or multiple sections. So if you come by one by one, definitely you will get success. Okay, please don't lose your patience. Do it patiently. Okay, So this is the case study of this particular PROBOOK HP motherboard. So anyway, you leave it. You forget about the motherboard model number. But what was the problem, and where from where to where we checked, and where we got the success? That is the moral of. That is the one major things we noted here. So have patience. So check thoroughly. Tata. Bye bye.